A Spanish company wants to launch a marketing campaign in 4 different social networks. We will use linear programming to decide how much of their budget they should invest in each social network. The campaign will last 3 years, but the amount of users of each social network changes every year, so we will use Markov chains to estimate the amount of users of each social network in the following years. The objective is to maximize the profit for each year of the campaign. We have a 1 million budget, 4 variables and 12 restrictions that we will explain later. An important concept to make the decision of where to invest is the return on investment, and this is calculated with this formula.
This is the amount of Spanish profiles in each of the social networks. This information was collected from databases, so this is real for the first year. But as we know, this changes frequently, so for the following years the quantities will vary. Maybe one social network is profitable today, but the next year maybe it's not. We created this transition matrix with the changes expected for the following years. To quickly explain this matrix, we can see that in the first column, 89% of Facebook profiles will remain active, but 6% will go to Instagram, 4% to Twitter, and 1% for YouTube. Each column represents the changes or migration for each social network. This matrix is applied in Markov chains to estimate the amount of profiles for each social networks in the following years. Each column, as you can see, must be equal to 1. This is the total users we saw before, and it is the information for the first year. The column matrix on the right shows how the total amount of profiles are distributed between these 4 social networks, dividing each of the quantities by the total. To calculate the distribution of the second year, we multiply the transition matrix T times the vector M1 for the first year, and we get M2. And we can turn these percentages into the quantities for the second year. Repeat the process for the third year, multiplying the transition matrix M times M2 to get the vector M3, and turn it into quantities.
Remember the return on investment formula. We will assume that the marketing cost is our 1 million budget. Now, we will calculate the return on investment of each social network for the first year. Assume that we invest the total budget in Facebook and that 11% of the total users are reached by the campaign. Then only 2.5% make an actual purchase of 20 euros on average. We get a 1.18 million revenue. And applying the formula, we get that the return on investment of Facebook for the first year is 18.14%. We repeat the process with the other 3 social networks, with their respective expected percentage rates. This process is repeated in each of the following years, using the total users we got before. This is for the second year. And this is for the third year.
Let's go back to linear programming. We have 4 variables, which represent the amount of money invested in each social network. We also have 12 restrictions. The first one is the budget constraint. The second one is the sum between Facebook and Instagram, and it must be less or equal to the 75% of the budget. Also, each social network must receive at least 125,000 euros and a maximum of 500,000 euros. And we also have 2 more restrictions. The objective function of the first year is based on the return of investment we got in the first part of the exercise, time each one of the variables. We want to maximize the profit in this year. We use solver complement in Excel to find the optimum values for each variable that maximize the objective function, taking into account the 12 restrictions. And now we have the best distribution of the budget for each year. We can also see clearly that Instagram became the most valuable at the end of the campaign, and that we will decrease our investment in Facebook in the third year. Also, Twitter, which started better than Instagram, is at the end a very small part of our profit, being the least valuable social network.
Thanks for your attention.